Here is question number 9 from your homework 10.3. It says a math teacher claims that she has developed a review course that increases the scores of students on the math portion of the large college entrance exam. Based on the data from the administrator, the scores are normally distributed with mean of 515. So original value is given to be 515. So we can write our null hypothesis that's of no change. The teacher claims that it's gonna increase her scores, right? So we can say alternate hypothesis is that the scores are better than 515. Let's check that answer. Okay. Now, teacher is obtaining a sample of 2000 students, put them through a review class. Because it's a random sample and the sample size is more than 30, we do not need to check normality. So random sample verifies our first requirement, and the second requirement says the sample size is more than 30, we are good. And the third requirement says that the sample size is less than 5% of all the students, so I think that should be okay. Puts them through the review class and finds that the mean math score of 2000 students is 521. So, so the sample size is given to be 2000 students. It's clearly more than 30. It's a large sample. So we are good with the conditions. Sample mean is given to be 521 and sample standard deviation is given to be 114. The question is asking test the hypothesis at alpha 0.10, say level of significance. The question is a mean math score 521 statistically higher than 515 or not? So let's first calculate the test statistic. Go to stat, go to the test. We need to run t-test because it's about mean. So select t-test and the stats are given. Okay. Original mean is 515. The sample mean is 521 and the standard deviation is 114. The size of the sample was 2000 and we want to check alternate hypothesis to be more than, so more than mu naught should be selected and then you press calculate. Okay, the t statistic is given to be 2.353. We need to round to two decimal places, so we need to write here, let's check that answer. Okay, next they're gonna ask p-value, that's also in the calculator. They're asking us in three decimal places, so 0.009 should be good. Okay, now what? We need to check the p-value comparative to alpha. So p-value is 0.009, it's clearly less than alpha, so that means we are gonna reject H naught, right? So if we are rejecting H naught, we are kind of accepting H1. Yes. So that means what? The value of p-value is less than alpha. That means the sample mean is statistically significantly higher. So because the alternate hypothesis, if you remember, is saying that the mean is higher than 515 and we are saying that we are leaning towards H1, we are accepting H1, right? We are rejecting H naught and we are accepting H1. That means it is statistically significantly higher. So, yes, it is true because the p-value is less than that value. We are rejecting H naught, so we are accepting H1. That means it is statistically significantly higher. Let's check that. Okay. Do you think a mean math score of 521 versus 515 will affect? Now, how small a difference that is, right? The school admissions, I don't think it's just how many points difference. 521 to 515, it's like 6 points difference. So it's not practically significant because the uh, it is not gonna be practically significant. Statistically, yes, we worked out our test and we are saying that it is increasing, yes. So, statistically significant, yes, but is it practically significant or not? Practical means in real life, do school administrators really change their decision based upon 521 versus 515? So, we're gonna say no, right? So, out of these two no options, the because the score is only very small percentage higher, so I'm gonna say it's 1.17% higher. It's not practically significant, that's why we are not selecting B. This is the correct option. Now what, the test statistic test the hypothesis at alpha 0.10 level. Now they are saying the sample size is smaller now. They change the sample size to 350. Assume that sample mean is still 521. So sample mean is still 521 and standard deviation is still 114. So we're going to run our test again on our calculator. Stat, go to test, t-test, enter. Now it's still statistics and the population mean is still 515. Everything is correct, but the sample is smaller. It's only 350 students and we want to test if the mean has increased. So press calculate. Now what do we get for the t statistic to the two round places? That is 0.98. Let's check the answer. Okay, and p value now is 0.163 to the three places. Okay, now what does it mean? Let's go back and check, because now p value is 0.163, alpha is 0.10, p value is more than alpha. So we are going to decide do not reject H naught, right? So that means we are gonna be, if we are not rejecting H naught, that means we are rejecting H1. So we are gonna say it's not statistically significantly higher. So is the sample mean statistically significant higher? We're gonna say no, because we are leaning towards H naught and the higher portion we are rejecting because H1 said it is higher. We are rejecting that. So it's no, because p value is more than 0.10. So this is the answer. Okay. What do you conclude the impact of large samples? So you remember how the sample size was bigger in the first problem and the sample size is smaller. Let's read. As n increases, the likelihood is of not rejecting null hypothesis increases, right? So that is not what happened. When the sample size was bigger, sorry, when the sample size was bigger, everything else was same, we rejected H naught. So likelihood of not rejecting that is wrong. As the n increases, the likelihood of rejecting null hypothesis increases. Yeah, we rejected, sample size was bigger, the null hypothesis was rejected. However, the large sample tend to overemphasize the practical significance difference. It was not practically significant, so no. As increases, the likelihood of rejecting null hypothesis increases. However, large samples tend to overemphasize practical insignificant of differences. As n increases, the likelihood is not rejecting the null hypothesis increasing. So I think this is the option.